Now today we are going to see expectation mainly in this lecture, which means that how to calculate expectation, what is expectation and what is the difference between expectation, average, and these kind of things we are going to talk about in today's lecture. So today's lecture is going to be very, very interesting, and there will be many interesting problems that we will solving with respect to expectation. Okay, so let's start. Now, as we already know that what is a random variable, now I think it is a correct time to introduce the type of random variables. So there are mainly two types of random variable. I mean, there could be many types. I mean, you can define your own type, maybe some hybrid of discrete and continuous. This could be some other type also. But mainly there are two types of random variable. One is discrete, another one is continuous. So discrete random variable, it takes either finite or countably infinite number of values. What does this mean? Let's suppose that x is a random variable. If I say that x is number on the dice, okay, whatever number it is coming. So on a dice roll, what are the possible values of x? What we will say? The possible values of x are, if it is number on the dice, then let's suppose it is six-sided die. Six-sided die. Then you will say the possible values of x are 1, 2, 3, 4, 5, 6. Right? These are the possible values of x. So is there anyone who is who is attending the probability class first time and doesn't know the this random variable, what is a random variable and all? I think, yeah, everyone here is almost same. Geetakshi, are you attending first time or you have attended previous lectures also? Okay. So as you see that these are the possible values that x can take. Now, what do you call that these values are finite or infinite? Like the x is taking these 6 values. So what do you think? These values are finite or infinite? Obviously, these values are finite, right? So it means that it is a discrete random variable. So if x is taking finite values, then it is a discrete random variable, and it can even take infinite values, but that infinite values has to be countably infinite. So there are two types of infinite, countably infinite and uncountably infinite. So it is, I mean, it is okay if you know these infinite. Otherwise that is okay. I mean, for our purpose, we won't be needing it much. But yeah, you will be studying that in either discrete mathematics that you might have studied, or you will be studying this in the theory of computation. So anyway, it is either finite or countably infinite. This is the discrete random variable. So this kind of random variable are discrete. Continuous random variables are one which take uncountably infinite values. Okay. For example, if I say that there is an experiment that can choose any point within this interval, maybe -1 to 1, then how many values are there between -1 to 1? How many values are there? Finite or infinite? Obviously, infinite values are there. Now, if I'm having a random variable that can take any value from -1 to 1, then since these are uncountably infinite value or uncountable values, then it is a continuous random variable. Okay. So for example, let's suppose there is a classroom. In this classroom, I want to the sample space are the students, and I want to map each student to maybe grades. Okay. So there could be many different random variables. Let's suppose there is one random variable which is a grade. And there is another random variable which is h. There is another random variable which is, let's suppose, a. So these three random variables does what? They takes the student and map it to either grade or height or weight. Now suppose the grade could be ABC, height could be anything from 120 to 200, and weight could be anything from 120 to 45. Then what do you think this grade is? It is a random variable, that is okay, but it is a discrete or continuous? This is a discrete random variable. Yes, Anurag. The reason being is that it is mapping to a finite values. If it is mapping to a finite value, it's discrete random variable. And what about this h? This h is mapping to height, and let's suppose that height could be anything. Okay, I mean, you are allowed to take any height in between 120 to 200. Maybe 120.0001 is also a valid height. Let's suppose. In that case, you will say that this height is a continuous random variable since it is mapping to uncountable infinite values. Similarly, this weight, let's suppose, I'm assuming that weight is also anything in between 45 to 120 kg, which means you can take any value, maybe 45.1013. Whatever precision you like, that is also okay. Okay. So you can take any values, let's suppose, then this weight is also, this A is also continuous random variable. So as you notice here, I have written, for example, weight and height. Weight and height are continuous values. That's why I will say that these are the continuous random variable. And since it is a finite values, and that's why I will say this is a discrete random variable. Okay. So discrete random variables and continuous random variables. These are the two types of random variables. So let's start discrete random variable in more detail. So in discrete random variable, we have a probability distribution for the random variable, and we call this probability distribution as PMF, probability mass function. So PMF is basically listing down the probability of each value of a discrete random variable, which means, let's suppose a random variable X, which could be anything, maybe number of heads in two tosses, let's suppose, which means the in two tosses it could be head, tail, head, tail, and tail, head, like that. Now this X will say that, okay, X will map this to 2, this to 0, this to 1, this to 1, right? This is your random variable X. Now if I ask you that what is the probability that X equal to 2, what is the probability that X equal to 1, what is the probability that X equal to 0, since X is taking 3 values, so you will say the probability, this probability is, I think, 1/4, and this X is 1, it is 1/2, this is again, sorry, X is 1, this is 1/4 into 1/2, and this is 1/4, X is taking 0, yeah, this is 1/4. Okay, because there is only one outcome that is taking participation in X equal to 0, which is TT. There is only one outcome that is taking participation in X equal to 1, which is there are two outcomes, HH, HT, and TH, and here you have HH. So this is your probability distribution, which means just tell me what are the possible values of X. How many values X can take? 3 values only, either 0 or 1 or 2, and you have probabilities for all of these 3 values. So this is called a probability distribution, or this is also called probability mass function. Okay, PMF. So PMF is listed down probability of each value for a discrete random variable, which means you list down for 2, you list down for 1, you list down for 0. Suppose if I ask you, if I do not give you any other value, suppose if I ask you probability of X equal to 3, then you will say it is 0. Reason being is that this probability summation is 1 and there is nothing else is left. Okay. Okay. So let's consider this question. They are saying, suppose that a coin is tossed twice. Let X represent number of heads. Oh, by coincidence, actually, I took the same example. So this is the example we just did. Let's have a different example. Let's suppose, check whether the function given by this is a PMF of random variable X. Check whether this function is a PMF, a valid PMF or not. So this is a notation of PMF, which means if you put X value 1, X can take 1, 2, 3, 4, 5. If you put X value 1, then you will be getting the probability of X being 1, which is 3/25. Similarly, if you put X equal to 2, then you will be getting the probability of X being in capital X being 2, which is 4/25. Similarly, you will be getting 5/25, like that. So can you check whether it is a valid PMF or not? What you will do, you will sum up all the probabilities, which means you will sum probability for X equal to 1 plus probability for X equal to 2 plus probability for X equal to 3 till probability for X equal to 5. Yes, Akash, that is correct, which means you will do 3/25 plus 4/25 till 5 means 7/25. So you can sum this up. I think this is 3 plus 4 plus 5 plus 6 plus 7/25. It should be 1. Can you quickly check it? 6 plus 5, 11, plus 4, 15, plus 3, 18, plus 7, 25, right? So this is 25/25, which is 1. So that's why it is a valid PMF. How we have checked? We have just summed all the values and then we said, like, okay, summation is 1, then it is a valid PMF. And obviously the second check should be that every of this probability should be greater than or equal to 0. And obviously that is true, right? Okay. So I hope now you are getting the meaning of PMF. Let's check this example. Now here we are saying that suppose that a pair of fair dice are to be tossed and let the random variable X represent donate the sum of the points, obtain the probability distribution for X, or they can also say the probability distribution means the PMF, which means they are saying you are rolling two dice, so a pair of fair dice, right? And then let X represent the summation of the numbers. So if we are rolling two dice, it could be 1 1, could be 1 2, could be 1 3, like that. Now tell me what are the possible values of X. It could be from 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? These are the possible values of X. I mean, it can range from 2 to 12 because summation can be at least 2 and at max 12. Now you need to find the probabilities for all of this. So what is the probability that it will get 2? It means the output should be 1, 1. That the probability is 1 upon, we have done it, I think, 1 upon 36. And here the output should be for 3, output should be 1, 2 and 2, 1. And the probability should be 2 upon 36. For 4, output should be 1, 3 and 3, 1, then 2, 2. That is okay, right? That is all. So you will be getting again 3 upon 36, like that. And for 5, maybe it is 4 upon 36. From this pattern, I'm assuming this is 4 upon 36. Should I check it? Let me just quickly check it. Maybe 1, 4, 4, 1. Okay. 2, 3, 3, 2. Yeah, this is 4 upon 36, right? Okay. So that's how you can get the PMF, and then you can say this is your probability mass function. Probability mass function means that you have to calculate the value of probability of X equal to small x or X equal to K or something, or whatever you want to call. So let me just call it X equal to dot. Okay. You can call it X equal to X, X equal to K, does not matter. So basically this is your probability mass function. Why? Because you have the probabilities for every random variable. Okay. Yeah. So this is your probability mass function. And yeah, so we are getting 1 upon 36, 2 upon 36, like this. And then after 7, we are getting 5, 4, 3, 2, 1 again. So anyway, so this is your probability mass function. Like generally we represent it px. Some people like to represent it with x, but f, but generally we represent with p. Okay, let me just write p here. Okay, this is PMF, probability mass function. Now, in words, I can say calculation of probability mass function goes like this: that collect all possible output that give rise to the event x equal to x. Which means if you want to calculate the probability mass function for this, then you have to collect all the possible outcomes. That for that the value is 3. You have to collect all the possible outcomes for that the value is 4. Right? There is no other way. So that's what it is written, that you have to collect all possible outcomes that give rise to event x equal to x and add their probabilities to obtain this. This means p x equal to x. Okay? I mean, these are different notations that people use, but anyway. Obtain px equal to x. I hope you got it. So what it is written, that you have to collect all the possible outcomes like this and then sum all the probabilities to get this one probability, which is 3 by 36. How I got this 3 by 36? Because for the 4, there are three outcomes that are contributing to x equal to 4. So that's why I got 3 upon 36, because I need to add all the probabilities. Okay. Now let's move to expectation. So PMF of random variable provides us several numbers, which means it provides us a table. So it is a PMF, which means for every x there is a probability. But suppose I want to summarize this PMF in somehow, like obviously in one number you cannot summarize the whole table. Whole table could be any longer. Maybe you can say it is having a 10,000 numbers, or could be anything, right? So whole table could be any big. But I just want to summarize it in just one number. Then I will say it is an expectation. Expectation is way to summarize in just one number. Which means, given a probability mass function, you can calculate just one number and you will say it is a summary of this probability mass function. And how do we calculate this summary? We will take a weighted average, which means if let's suppose this value is x and it is given to me that x is taking 1, 2, 3 like this, with the probability, let's suppose 1 by 3 and anything, okay? 1 by 3, 1 by 3, let's suppose these are the probabilities. Then how do I calculate the expectation? I will take the weighted average, which means I will multiply these two, multiply these two, multiply these two, which means 1 into 1 by 3 plus 2 into 1 by 3 plus 3 into 1 by 3. This is called expectation. So basically expectation, you can say that it is like, actually I'm talking a bit informally, but you can say it is a number that you are expecting, which means that out of all the probabilities, what is the average number, like you can say that on average that what we are expecting. Okay, if you want to expect something, then it is a best hope to expect for this number, something like this. It is not exactly this. Okay, so I will tell you the relation that why it is not exactly this, but for now I'm just saying it is some number where that you can say that you are expecting on average. So let's just see examples. So see, I can say expectation from the physics point of view is that it is same as the center of mass, which means let's suppose that in the physics I have some weight here, maybe some weight here, some weights here, some weights here, some weight here, some weight here, some weight here, some weight here. Then where do you think the center of mass will be? Maybe here in the middle, or maybe little bit towards this higher weights, right? Because it is having the higher weight, so just to balance it will be on the left side. Okay. Ekta is saying high probability, that high chances. No, it is not like that. It does not say anything about the probability. Expectation does not say anything about the probability. It is not like that. It is the high probability is there. If you take the average, then it will be 3 plus 2 plus 1, 6 upon 3, which is 2, right? It is not like that you will be getting 2 with the higher probability or like that. No, expectation doesn't say anything about the probability or anything. Okay, it is just that on average you can expect 2. And what do I mean by that on average you can expect 2? You will get to understand in a while when I will talk about the difference between expectation and average. So basically, from the physics point of view, if I just ask you the center of mass, if you remember from your 12th class mathematics, like if you remember, that is okay. Otherwise also fine. So basically, center of mass is a point for any physical object where you will say the gravity lies on, like as far as I remember, which means this is a balancing point. If you balance on this point, if you put a hinge on this point, this scale will not move. Right? Do you remember the center of mass thing from the physics? So this is same as the expectation. So expectation also works like this, which means suppose there is a probability mass function PMF. Okay, PMF is there. Let me say there is a PMF where the probability that 12 will appear, it is having, let's suppose, very less probability, maybe 1 upon 10, something like this. Probability that 10 will appear, maybe it is having maybe higher probability, maybe 2 upon 10, something like this. Maybe probability 8 will appear, it is having maybe little lesser probability, maybe 1 upon 10, something like this. Okay, so let's assume that there are probabilities like this. Maybe it is 1 upon 10, 1 upon 10, anything. Okay, 1 upon 10, 1 upon 10, I don't know, 3 upon 10, maybe it is higher. Let's suppose it is 1 upon 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, great. So yeah, so these are this is a valid probability distribution. Okay, so I got a valid probability distribution by coincidence, which means if I just assign this this value, which is 1, let's suppose the probability of 1 is 1 upon 10, probability of 3 is 3 upon 10, probability of 4 is 1 upon 10, probability of 5 is 1 upon 10, probability of 8 is 1 upon 10, probability of 10 is 2 upon 10, and probability of 12 is 1 upon 10. Then can you calculate the expectation? Expectation will be 1 into 1 plus 3 into 3, like this. So which means 1 into 1 plus 3 into 3 plus 4 into 1. This is one term, this is another term, this is another term, plus 5 into 1 plus 8 into 1 plus 10 into 2 plus 12 into 1 upon 10. Okay, I mean you just need to take a average like this, 1 into 1 by 10, 3 into 3, whatever, like this. So it is 9 plus 1, 10, 14, 19, 19 plus 8, 27, and then plus 20, 47 plus 12, 47 and 12, 59, 59 upon 10, which means 5.9 or almost 6. So the expectation will be 5.9. So as you can see here, the expectation will be here, just lesser than 6. Reason being is that you are having higher mass at the left side. Right, you are having higher mass at the left side. That is why the expectation is moving on the left side. Okay, it is very similar to the center of mass, which means instead of the physical objects here, you have the probability masses. Instead of the physical masses here, what do you have here? The probability masses, the probability mass. It is also a mass, but it is just a probability mass. That's what we call in our probability theory, probability mass function. Okay, so you can just relate it that there is a center of mass, and the center of mass is analogous to the expectation. Now suppose if I ask you that there are given numbers with any probability, whatever probability you have, maybe let's suppose that there are some numbers with any probability, maybe it is having higher probability, it is lesser, it is higher, maybe something like this, any probability like that. So this is maybe, let's suppose, I mean, obviously it has to be less than 1. Suppose this is 1 by 3, very, very good probability. This is 1 by 3. This is, let's suppose, 1 upon 10, very less probability, like that. Let's suppose these are some probability distribution. Now tell me, if you find out the expectation, expectation is basically the center, okay, center of mass. Can the expectation will be on the left side? Final result, if you find the expectation, whatever it is, can the final result, the center can be on the left side? It is a center. So it cannot be on the left side. It cannot be on the right side. It has to be on the middle. I mean, middle in the sense it will be obviously compensating that wherever you are having the higher mass. But yeah, it is almost in the middle, right? Maybe here in this case. But it cannot be either on the left or right. It can never be like this in this case, right? Okay, ठीक है, ये समझ में आ गया, right? So expectation को you can say it is a center of mass, which means in the physical sense you can compare with the center of mass. In the logical sense, that you can say it is a summary, or it is a number which you can expect in a long run. I mean, actually the definition, I don't know if I can tell at that point in time. Basically, it is okay. Let me tell you one line. You might not get it, but let me tell you. It is not something that you are expecting, okay, which means you might not get that number at all in the infinite number of trials also. But if you take average of all the trials, okay, if you run your experiment long enough, you take the average of all the trials, then it is a one number that the expectation represent. You will get to understand this in the little while. Okay? So Ekta is asking 10 is total number or total no with non-zero probability. 10 does not matter. I mean, what is this 10? I mean, why do you bother about this 10? 10, like, I do not care about the 10. Yes. So it is just a probability distribution, whether it is X, Y, Z, anything. Okay. So it could be anything. Let's consider this question. They are saying consider a roll of dice. You get I rupee if outcome is I, which means that you toss a dice. It could be 1. Outcome could be 1. Let me write the outcomes. Outcome could be 1, could be 2, could be 3, could be 4, could be 5, could be 6. Now what they are saying, that you get I rupee if the outcome is I, which means that this is the outcome that you are getting, and if outcome is 1, you will get 1 rupee. You get, okay, you will get 1 rupee. Here you will get 2 rupee, because they are saying that if outcome is 1, you will get 1 rupee. Outcome is 2, you will get 2 rupees. Here you will get 3, 4, 5, 6. Okay. How much do you expect to get per try? Which means if outcome is 1, you might win the 1 rupee. If outcome is 2, you might win 2 rupees. How much do you expect on average for each try? Which means you roll a dice. Okay, you are getting question. You roll a die, and then if I ask you that what do you expect, how much you will win, it means that you roll a die, then how much you expect to win. What do you think? What is the answer? So I'm asking about the expectation of rupees, right? How much rupees you expect. So whenever you ask about any expectation, then what you need to do, you take that quantity rupees, and then you write the probabilities. Okay, these are the probabilities. Now tell me, what is the probability that you will be winning 1 rupee? 1 by 6, right? You will be winning 1 rupee because outcome is 1. You will be winning 2 rupees because outcome is 2. You will be winning 3 rupees if the outcome is 3, like that. So whenever I ask you expectation question, just make, I mean, you are making whatever you are making in the table, that is okay, but just always make two columns. One column is that just first identify, I'm asking expectation of what? Expectation in terms of rupees, right? The unit of the final answer is what? It is rupees. So just write the rupees and the probabilities associated with that. That is all you need to do. Okay. So for any expectation question, just always try to figure out those two columns. What is the probability? What is that particular X or the rupees or anything that they may ask? So now the expectation will be just multiply these things. Just multiply these things. Just multiply these things. Multiply these things. Okay. Which means it is 1 into 1 by 6 plus 2 into 1 by 6 So once you get these two columns, okay, once you get these two columns, you just multiply these two columns side by side. And then this is 3 into 1 by 6. And then finally it is 6 into 1 by 6. If you calculate it, it will be 3.5. So what does this 3.5 number represent? It says that, like, I mean, it says basically in this case that you can expect 3.5 rupees in just one try, which means if you roll a dice, maybe 3.5 can appear. No, sorry, you may win 3.5. Okay. And if you do it multiple times, if you do it n times, then the answer will be 3.5 into n. Like, why I'm multiplying with this n, you will get to understand when I explain you linearity of the expectation. Okay. Which means in every trial, if you're getting this, then in n trial, you will get 3.5 into n. Ekta is asking 1 upon 21 will not take. 1 upon 21. From where you are getting this 21? Sum of the rupees. No, you do not need to. Okay, don't get confused with this. Like, what you need to do, you need basically the expectation formula. I think I have not told you yet, but it is x into px, which means the quantity that you have and the probability of this quantity. The quantity is 1, and the probability that you will be winning 1 rupee is 1 by 6 probability, not with 1 by 21 probabilities or 2 by 21 probabilities. Okay, 1 by 6 is the probability that you will be winning 1 rupee. 2 into 1 by 6 is the probability that you will be winning 2 rupees. 3 into 1 by 6 is the probability that you will be winning 3 rupees, like that. Okay, and then 6 into 1 by 6. Then finally 3.5. Okay. So one is asking that how 3.5, because rupees in the whole number. See, this 3.5 represent a number that says that this is an expected number. Okay. Expected number means that if you run your experiment multiple times, then on average, you will be winning 3.5 rupees, which means that basically it says that if you are playing this game, let's suppose this is a game, and then you are rolling a die, and then based on the probability, I mean, based on the number, you are getting a rupees. If the number is 6, you are getting 6 rupees. If the number is 5, you are getting 5 rupees. Now suppose you roll it one time, maybe the number is 1. How much you will be getting? If you roll it one time, maybe the number is 1. How much rupees you will be getting? 1 rupee. Let's suppose you roll it again. Okay. So okay, let me just try to explain it. Let's suppose that you roll it one time, you got it 1, you got 1. Okay, one outcome. I'm writing outcomes. Let me first write outcomes. You get 1. Let's suppose you roll it 2 again. Can you get 1 again? Obviously you can get 1 again. I mean, there is no problem, right? You can get 1 again. Mathematics doesn't deny this. I mean, there might be a less probability, but mathematics doesn't deny this. Can you get 1 again? Yeah, you can get 1 again. There is no problem. Can you get 1 again? Yeah, you can get 1 again. There is no problem. Can you get 1 again? Yes, you can get 1 again, right? I mean, you can get 1 in continuously. It's not like it is a 0 probability. There might be less probability, but it is not a 0 probability for sure. Okay. Okay. Can you, okay, but let's be very little practical. Let's suppose you are getting 1, then can you get 3 again? Yes. Can you get maybe 5 again? Yes. Can you get 1 again? Yes. And can you get maybe, let's suppose 2? Yes. Can you get 6? Yes. Can you get 1? Yes. Can you get 2 again? Maybe 3, maybe 4, maybe 5, like this. Like there could be any number of there could be any number. But tell me, is this, like, whatever I'm getting here, the outcomes that I'm getting here, can it be like, is it random or is it following some pattern? The outcomes that I will be getting here, pattern in the sense, some mathematics it will be following, some universe nature it will be following, or it will be just random? It is a random, that I completely agree, but there is one thing: it will follow the fairness of the die, which means if die is fair, then you cannot get 1 every time. Right? I mean, you can get, I mean, mathematically you can get, but practically I'm saying, let's be practical for a moment. I will tell you that why I'm saying this practical thing. Okay, practically you cannot get 1 every time. I mean, mathematics is okay, but if die is fair, then it has to give you somewhere 2, it has to give you somewhere 3. Let's assume that you are rolling it infinite number of times. then obviously you cannot get one infinite number of times, right? You have to get 3 somewhere, you have to get 5 somewhere if die is fair. So basically it will follow the probability distribution, that the probability distribution is that probability of x equal to 1 is 1, which means that it will give you 1. The chances sorry, this is 1 by 6. It will give you 1. The chances are that on average, like if you roll it 6 times, then you may get 1. I mean, in just 6 times, you may get one time. Okay. So just see 1, 2, 3, 4, 5, 6. In 6 times, you are getting 1, 2 times. That is okay. But on average, maybe let's suppose you're okay. Do you remember the first class of the probability, the first few minutes that I have defined the probability like this? That what does this mean to say 1 by 2? The probability 1 by 2. Does this mean that you're tossing 2 times, you will get a head 1 time definitely? No, right? Does this mean you're tossing 4 times, you will get 2 times head definitely? 2 heads? No, right? Does this mean from the 8 times you will get 4 heads? No. Then what does this 1 by 2 mean? It means that if you roll enough number of times, yes, enough is the key. Now you may ask me, what is enough? Is 10,000 enough? I will say I don't know. Okay, maybe 1 million is not enough, maybe 1 billion is enough, maybe 1 trillion is enough. So these are the theoretical definitions. Okay, don't ask me what is enough. Enough is anything. I mean, and enough is any finite number. If you just say that, okay, I have rolled it 10,000 times and I'm not getting almost half, like what is happening here? I have tossed enough number of times. And I mean, if you come up with me, I say the probability of head is equal to 1 by 2. And you come up with me that, okay, you say that I have rolled enough number of times. I'm not, which means I have rolled 10,000 times and I'm not getting almost 5,000 times. I'm just getting 2 times. Okay, out of 10,000, I'm getting two times head. Then what will I say? What will I say to you? I will say that, see, you are saying enough, but it is actually not enough. Okay, maybe what about you just toss it 1 million times? What about you toss it 10 million times, like that? I mean, these are just theoretical number. You cannot say that 10,000 is enough or 20,000 is enough. But we have seen that practically, in fact, like people have rolled 2,000 times, to toss 2,000 times. If you remember that first slide, I've shown you that some mathematician actually tossed 2,000 times, and one of them had got 996 times head, or like something like this. So anyway, these are the theoretical numbers. So why I'm bringing it here? Because it is very much related to expectation. The definition of probability is very much related to expectation. See, these numbers, whatever you are getting, is okay, but they have to follow some probability distribution, which means, let's suppose, for example, let me take a smaller example. Let's suppose I say the probability of head, suppose I say it is 2 by 3. Probability of tail is, let's suppose I say 1 by 3. Okay. Suppose this is the distribution that I have, which means I have an unfair coin or a biased coin. Okay. Suppose I have a biased coin. Now I toss it. Tell me, is this possible? I mean, okay, let's not worry about the possibilities. Let's see that what's going to happen in practical. I mean, if you toss it, let's suppose 50 times, then tell me, is this okay to write like this? Maybe head will appear, right? Head will appear. Then maybe tail will appear. Maybe then head will appear, and maybe tail will appear. Maybe head, and then tail, head, right? Like that. I mean, maybe something like that. Now tell me, is this okay? Let's just see. Which means that if you have this kind of distribution, and then this is called sampling the data, and you're sampling the data, which means you are actually running the experiment, and then you are collecting the data. Okay, underlying distribution is this, and then you're collecting the data. Then tell me that, is this a justifiable data? Like, can you get this data? Tell me how many heads you have got here. 1, 2, 3, 4, 5, 6. 6 heads you have got out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10, which is maybe you can say it is 5 of, oh sorry, it is 3 upon 5, right? It is 3 upon 5. And tails will be 4 upon 10, which is the tails, which is I think 2 upon 5. ठीक है, मतलब कोई प्रॉब्लम नहीं है. मतलब basically maybe if I run it multiple times, maybe let's suppose if I run it enough number of times, ठीक है, तो let's suppose I'm running it 15 times. ठीक है, अभी 10 times हुआ है ना. Let's suppose I'm running it 15 times. In 15 times, let's suppose I get a tail, head, maybe tail, head. Let's suppose I'm getting this kind of values. Okay, suppose I'm getting this kind of values. It will take some time to understand, but probably you will get to understand. Let's just see that what is happening here. So what is the probability that I'm getting for the head? Just see, out of 15, how many times I'm getting head? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times, right? Okay. And tail will be 5 times. Okay. 1/3 and 2/3. Maybe I can match my original distribution. Maybe I cannot match. Basically, I mean, this is just a sample. Okay. So these just tell me, are these real probabilities or these are the real probabilities? Which one are real probabilities? This one or this one? Which one has the real probabilities? No, both are not real probabilities. These are the real probabilities. And what is this? What is this? This is just a sample probability. I just drawn one sample. I got these properties. I was very lucky that my probabilities got actually matched. Otherwise, in practical, it doesn't happen. Maybe in practical, I will get just this one head and this tail will not match the exact numbers, right? Maybe it is 9/15, it is 6/15, right? If this instead of head, I could have got tail, then maybe the exact number won't match, but it will be close. It will be close, right? Yes, it depends on number of trials. Yes, that's very good. So basically, if I draw some sample, let's suppose I do not have enough data. Then from this data, I am inferring the probabilities. These are called sample probabilities. Okay, sample probabilities. So if I'm drawing some probabilities from the data, then they may not match with my actual probability. That is okay. But what does the probability definition say? Probability definition says that if you have enough data, if you have enough number of trials, maybe let's suppose I draw it 10,000 times, okay, then what my probability will come like this. Maybe in 10,000, I will say out of 10,000, or maybe let me have some number here. Maybe let's say out of 9,000, let's suppose I draw it 9,000, then on average, almost I will be getting maybe 6,000 times head, right? Do you all agree? If the probability, underlying probability distribution fixed, okay, no one can change this. No one can change this. This is fixed. No one, absolutely no one can change it. What we are doing, we are just drawing this data from this distribution. We are sampling some data from this distribution, and then we are trying to approximate our probabilities. So the approximated probabilities will be changing based on the data. If maybe if let's suppose I just do 9,000 one times, maybe the next time tail is appearing, maybe this is the probability that I'm getting, right? So anything can happen with the sample probabilities, but the real probabilities are fixed. So coming to the point is that I was saying about the expectation. So basically, expectation tell you that on average, which means if you run your experiment enough number of times, then what is the average that you will be getting? Okay. Okay, don't worry, it will be more clear with some more lectures, or maybe after maybe half an hour I will be telling you about the differences between the expectation and average. But for now, I'm just telling you few things, that this is the real probability which is fixed, and these are the sample probabilities. Okay. So I just wanted to let you feel the probability distribution, that what does this probability distribution mean. So in real world, what does happen? What do you think? Do I have this real probabilities? What do you think? Just guess it. I know that you might have a random guess, but what do you think? In real world, do I have the random these probabilities? The absolute probability do I have in my hand? No, that's the problem. Okay. In real world, I do not know this. Then what do? I just have a coin. I will just flip it multiple times. I will get some data. I will gather some data, and I will try to infer the probabilities. Yes, exactly. So in real world, I do not have this. Okay, real world is not that fair. I have this only. I have the sample probabilities. I do not have the real probabilities. Okay. So why do you think that all the companies are running towards the data? Why companies are running for the data? Because more data makes you this number more stable. The more samples you have, you will be more confident that okay, your probability distribution looks like this. I mean, that's your sample probability distribution, but that is okay. I mean, your sample probability distribution will tend to be your real probability distribution. The more data that you have, right? You all agree that more data, which means more stable probability numbers. And why do they even care about the probabilities? See, let's suppose there is some probability distribution of anything, any data. So what does happen if you know the probability distribution, which means let's suppose that one of the probability distribution in one of the example, I think x plus 3 upon, what was that? X plus 3 upon, कुछ तो एक example था ना? 25 है ना, x plus 2 upon 25. ठीक है, मतलब होगा क्या कि let's suppose that you have approximated that your probability distribution look like this. I mean, it will be some closed form, something like this. Then what does this happen? If let's suppose you're more confident that yes, this is my probability distribution, then what will happen? You do not need data anymore. See, probability distributions are so powerful that, see, what does happen, that from this data, you have gathered the probability distribution, that is okay. But once you say that my probability distribution is stable, which means that it is the real one, okay, it is the exactly the real one, then do you need this data anymore? This data does not matter to you. I mean, this is useless data once you have the probability distribution. In fact, you can generate the data. You will say, let me simulate the data. Okay, now you will be the god. If you have the probability distribution, you are the king of industry, which means for any given data, if the machine learning, if I tell you that what is the machine learning is all about, it's exactly same as finding the probability distribution. Basically, we just try to find out the probability distribution. If we get the probability distribution, and then we say that, okay, now I have everything, and now I can even generate the data. I can predict anything. If you ask me that that x will take the value 5 or not in future, I will say, let me just check, because I have the probabilities for everything. Okay, and if you ask me in future whether x will take the value 5, I will say, see, this is the probability for x being 5, which means 7 by 25. Then I will say, no, it is a good probability. Okay, I will say it is a good probability. Maybe it will take with this probability, like that. Okay, which means if you have the probability distribution, you can predict the future, whether in future x will be 5 or not, x will be 6 or not, like that. Okay, so you can predict the future if you have the probability distribution. So getting the real probability distribution is the challenge in machine learning, and that's what people are trying to do. So basically, it is a cycle. You have the data. This data, basically, it is a cycle in the sense you gather the data. Okay, then you tell that, okay, this is your probability distribution. And then sometimes what happens, you generate the data using this probability distribution. I mean, these are some typical modeling, obviously, the very complex things. These are called prior probability and then posterior probability and these kind of things. You generate the data and then you do something, then you again draw the probability distribution, and this is a kind of cycle. Okay, I mean, people are trying to do many kind of things in machine learning and using many different techniques. Anyway, so coming to the expectation is basically a average only, but average on a long run. Why? Because let me tell you, let me not wait for anything else. I was waiting for that slide to come, but let's not wait. I mean, let me just try to answer here, and maybe later also I can answer if there is any doubt. So just tell me average. What is an average? And then you will get to understand this expectation mode. Okay, what is an average? Suppose that you have some numbers, maybe 1, maybe 2, maybe again 1, maybe 5, maybe 2, and any set of numbers, maybe 3, maybe 10, maybe 20, like that. Okay, you have some numbers, maybe 10 again, like this. Okay, maybe 5, like this. Now let's take the average. What will the average? What you will do? You will do 1 plus 2 plus 1 plus 5 plus 2 plus 3 plus 10 plus 20 plus 10 plus 5. Okay. Okay. Let's have some example, which means let me tell you one example. Let's suppose that you are playing a game. Maybe you are playing a soccer game, and then these are the scores that you make. These are the goals that you make in first match. Maybe in the first match you got 1 goal, and the second match 2 goals, like that, and 5 goals, like this. Okay, maybe 6 goals. ओके दिस 10 इज टू मच, बट ठीक है, कोई प्रॉब्लम नहीं है, चलो 10 वाला नंबर हटा देते हैं, ठीक है. Let's suppose these many goals that you got in the first match, second, for one goal, two goals, and one goal, like that. If I just ask you what is the average number of goals that you get, then what you will say? You will say that average number of goals will be this plus 6 plus 5 upon 1 2 3 4 5 6 7 upon 8. ठीक है, ये सही है ना? Average number of goals. Okay. Now tell me what you did here. Have you taken any probability or these things, or you just took the simple average? You just took the simple average. ठीक है. Whatever this number, I'm not interested in this number. Let me just rewrite this number in some interesting way. Okay, I'm just rewriting this number. This is 1 2. Okay, 1 is coming 2 times. Okay, 1 is coming 2 times, plus 2 is coming 1 2 times again. Maybe let's say that 2 is coming 3 times. I mean, just for the sake of example, I'm saying that okay, 2 is coming 3 times. Okay, so this will be 9. Anyway, it does not matter. Just for the sake of example, I'm saying 2 is coming 3. So 2 is coming how many times? 3 times. 2 is coming. 5 is coming 2 times. 2 हो गया. 3 is coming just one time. 3 is coming just one time. 6 is coming just one time. And 5 and 2 हो गया. ठीक है, upon 9. Okay. Now let me just rewrite in this way. 2 upon 9 into 1 plus 3 upon 9 into 2 plus 2 upon 9 into 5 plus 1 upon 9 into 3 plus 1 upon 9 into 6. ये रीराइट किया, ये सबको समझ में आया? ये 2 upon 9 किया, 3 upon 9, 2 upon 9, 1 upon 9 and then 1 upon 9. ठीक है, ये रीराइट कर लिया मैंने. This is 1, this is 2, this is 5, this is 3, this is 6. Tell me, is this expectation or this average? Again, average, right? I mean, you took the average, this is just average. I mean, I have just rewritten, that's okay. ठीक है, इतना समझ में आया. तो एवरेज में what we are doing, we are basically just doing a plain average. Are you considering the probabilities here? That इसकी क्या probability है, ये क्या probability है, इतना कुछ दिमाग लगाया क्या? नहीं, right? But you are actually considering the probabilities. How? I mean, you do not know this, but you are doing it. How? See, this 1 is coming 2 times. You have said like, okay, the probability of 1 is 2 upon 9. The probability of 2 is 3 upon 9. The probability of 5 is 2 upon 9. The probability of 3 is 1 upon 9. The probability of 6 is 1 upon 9. Which means what you actually did, I mean, you took the average. मतलब तुम भोले भाले हो, तुमने कुछ नहीं किया, but हो क्या गया वो मैं बता रहा हूँ. ठीक है, कि you took the average and then unconsciously or the subconsciously what you did, you found out the probabilities from this data. Tell me, using this data, okay, actually I never know the actual probability distribution of any data, but using this data, tell me the probability of 1. How many times 1 is coming? 2 times upon 9. Tell me the probability of 2. Probability of 2 will be how many times 2 is coming? 3 times upon 9, right? Tell me the probability of 5. Probability of 5. How many times 5 is coming? 2 times, like this. So basically what you did, you actually calculated the probabilities and then you calculated the expectation. I mean, you calculated the average, I agree. But ultimately, what you actually did is basically you found out the probabilities from the sample data and then you took the average. You took the expectation. Isn't it the expectation? If this is the probability, this is the number. Isn't it the expectation which looks like this, xpx? So what is the difference between expectation and average? If this is also expectation and this is also average, की थोड़ा mix हो गया ना? क्या difference है? क्या लगता है? See, it was average, but I am saying it is an expectation. तो फिर difference क्या रह गया? You're getting my question, right? Sudeep, what do you think? What is the difference? See, we took the average, and now I just concluded that this was not the average. This was actually the expectation. Interpretation का difference नहीं है, कुछ बड़ा difference है. Interpretation is okay. See, what is happening here? Tell me, are these real probabilities? Are these real probabilities? और these are some sample probabilities. मतलब हो सकता है कि कल कोई probability change हो जाए, right? कोई भरोसा नहीं है ना. These are just a sample probabilities. So that's the only difference. Okay. Average is expectation only, but your probabilities are not real. That's the problem. You're getting the point? Average is expectation only, but the probabilities are not real. Probabilities are not real. These are sample probabilities. Probabilities are sample probabilities. Okay, I will tell you more detail. Don't worry. I will make sure that you are getting it. So basically, you took the average, but it is not the expectation really. It is average only. Reason being is that in the expectation you have the real probabilities, real probability distribution. Then you call it expectation. Now suppose I do what? Not just 9 times. This was just a 9 time, not just 9 times. Suppose I run it 1,000 times. I play the soccer game 1,000 times, maybe 10,000 times. Okay, I run my experiment 10,000 times. Then I will be getting a huge numbers. I mean, not huge numbers. Sorry, I will be getting a huge data, right? Maybe if I run the experiment 10,000 times, then I will be getting something like this. Maybe 6, 5, I don't know, maybe बहुत सारे number होंगे ना, 5, 6, again 3, 2, maybe 4, like this, right? Maybe 7 sometimes. Maybe if I run it 10,000 times, then there will be a huge data. Do you all agree? Obviously, मतलब 10,000 data points होंगे, right? In that case, if these are the 10,000 data points, in that case, if you take the probability, the sample probabilities, now you calculate the sample probabilities, won't it be almost close to the real probabilities? I'm not saying it can be real probabilities, but I'm just saying it कि अगर मतलब data points enough है तो मतलब थोड़ा अच्छा approximation मिल जाता है अपने को, नहीं? तो if you have enough number of data points, so your probabilities in this case, if we have enough number of data points, then I can say your sample probabilities are actually almost ठीक है, मतलब almost बोल सकते हैं, ठीक है, almost same as real probabilities. Which means अगर आपने बहुत ज्यादा एक्सपेरिमेंट रन कर लिया है एंड देन यू आर टेकिंग एवरेज, इट इज अ गुड एवरेज, राइट? ऑब्वियसली अगर आप ज्यादा ज्यादा बार एक्सपेरिमेंट रन करके एवरेज ले रहे हो तो प्रिसीजन अच्छा आएगा ना. That's what we do in the physics labs. I mean, in the first year or second year, that's what we do. हम अगर कोई भी चीज मेजर कर रहे हैं, we just don't do it 1 or 2 times. मे बी 4-5 बार लाइक इंस्ट्रक्टर वो टीए कराते हैं. क्यों कराते हैं? क्योंकि जितनी ज्यादा बार कोई भी एक्सपेरिमेंट परफॉर्म करेंगे तब एवरेज लेंगे तो एक अच्छा एवरेज आता है. रीजन क्या है उसका? क्योंकि हम अच्छे से प्रोबेबिलिटीज अप्रोक्सीमेट कर पा रहे हैं. In that case, the sample probabilities are actually the real probabilities. I mean, almost real probabilities. So basically, if you take the average on the huge data, then it is an expectation. Okay. In other words, I can say basically मैं ऐसे मतलब ये बोल सकते हैं, but in other words, that is a better words. Let me write better words to say. You can say that average is same as expectation if we have huge data. ठीक है, large data. Or if we in a long run, you can say in a long run, average in a long run, average tend to expectation. पूरा खेल probabilities का है. Like if you have the real probabilities, you have the expectation. If you do not have the real probabilities, then what you do? See, if you have the real probabilities, then yes, you have the expectation. If you have real probabilities, then you have expectation. If you do not have real probabilities, then I mean, then do one thing. I mean, yeah, you have the average, but then at least run your experiment enough number of times. Then run experiment enough number of times, then take average. Now, if you ask me what is this enough, is 10,000 enough? Tell me, is 10,000 enough? Is 10,000 enough number of times? It's not like no or yes. It's like we don't know. Okay, we don't know. I mean, maybe it is enough. We don't know. Yes, Sudeep, that is right. We don't know. These are the theoretical definitions. You cannot ask me 10,000 enough or 2 is enough or like that, right? So yeah, so I hope you got it, the difference between expectation and average. So I can say that expectation is nothing but average for the long run, right? So if I say the expectation is same as average for long run, or in long run, whatever, in long run or for long. So basically, if I say that you can expect some number, maybe you can expect 3.5 out of the rice roll. It means if you maybe like if I'm saying here that you can expect 3.5 rupees, if I'm saying you can expect 3.5 rupees, I mean to say that if you play enough number of times, okay, if you play enough number of times, then on average, in some trial you may win 1, in some trial you may win 2, in some trial you may win 6. That's okay. But if you play enough number of times, then on average you will be winning 3.5 rupees. That's what I mean to say. Everyone got it? That what does this expectation mean? That if you play enough number of times, then you will be getting 3.5 rupees on average. दिस इज द एवरेज नंबर, ठीक है। चलो एनफ नंबर ऑफ टाइम्स को मैं बार बार नहीं बोल रहा, हो सकता है कि वो कंफ्यूज करे, तो मैं ऐसे बोलूंगा कि ऑन एवरेज यू विल बी गेटिंग 3.5 रुपीज। अगर तुमने 10-20 बार खेला है तो 20 बार में, ठीक है, 3.5 रुपीज ऑन एवरेज यू विल बी गेटिंग। दिस इज व्हाट प्रोबेबिलिटी सेज। अगर लेट्स सपोज कि कल को यू डू अ गैम्बलिंग एंड इफ यू डू नॉट विन लेट्स सपोज गुड रुपीज इन लेट्स सपोज 20 टाइम्स एंड यू कम टू मी दैट सर आपने बोला था कि लाइक आई विल बी विनिंग सम रुपीज इफ आई प्ले 20 टाइम्स, देन आई विल जस्ट से, I will say what? Can you guess what I will say? I will just say that you have not played enough number of times. अभी खेलो थोड़ा और, ठीक है, 50-60 बार खेलो। फिर लेट्स सपोज कि 50 बार खेल के एंड देन यू कम बैक टू मी एंड देन यू से सर आई एम लूजिंग एवरीथिंग and you told me that you will win 3.5 rupees at least. So I will say no, you are not playing enough number of times. और खेलते जाओ, ठीक है। That's what I will say. So basically these are the theoretical definitions. Okay, you cannot say me that okay मैं तो 10 बार, like I have played 10 times and I'm not winning the game. Maybe you need to play 10,000 times, and then once you play 10,000 times, then also I cannot claim कि वो आ जाएगा, right? But yeah, these are the theoretical things कि expectation tells you that on average if you play enough number of times, then you will be winning these much rupees like this, ठीक है। Okay, so let's move to this question. Now they are saying consider a roll die, consider a roll of die, and then you get I square rupee if the outcome is I, which means outcome could be could be 1, could be 2, could be 3, could be 4, could be 5, could be 6. ठीक है, and then let's suppose these are the rupees that you get. If 1 comes, then how many rupee you will get? 1 rupee. Here 4 rupees, here 9 rupees, here 16 rupees, here 25 rupees, here 36 rupees. Okay. And then let me write the probabilities of these outcomes probably here or anywhere, like does not matter. So the probabilities of the outcome, this is 1/6, this is 1/6, this is 1/6, this is 1/6, this is 1/6. And then tell me what is the probability that you will be winning 1 rupees You will be winning 1 rupees with probability 1 by 6. This probability 1 by 6, you will be winning 9 rupees like this, right? Now just take the just make these two columns, and if they're asking about the expectation of these rupees that on average, that or what do you expect to win on average, then you will say, let me just take the let me draw the two columns, and let me just take the product like this, right? 1 to 1 product, which is 1 into 1 by 6 plus 4 into 1 by 6 like this, plus 9 into 1 by 6 like this, plus 16 into 1 by 6 plus 25 into 1 by 6 plus 36 into 1 by 6. Okay, and you will get your answer. So this is in just one trial. I mean, one trial on average, you can expect this. What about the n trials? You will just multiply by n. Why we are multiplying by n? I mean, we can easily prove it using the random variable and using the linearity of expectation, but we will do it later. Okay. For now, understand, whatever you get in the one trial, if they ask in the n trials, you just multiply by n. We will do it later. Okay. This is called linearity of expectation. And I mean, basically what you will do, you will define a random variable for each trial. Let's suppose x1 is the random variable for first trial, x2 is a random variable for the second trial, which means x1 is the rupees that you are getting in the first trial. X2 is the rupees that represent X2 is a random variable that represent rupees in the second trial. And then finally, I will ask you to calculate x1 plus x2 plus x3. Then using the linearity of expectation, you will say it is E of x1 plus E of x2. And then since x1, x2, x3 are all are equal with the symmetricity, it will say 3 into E of x1, something like this. Okay, so we can prove it later. I like those people who are already comfortable with this expectation, linearity of expectation, these kind of things. Though those people might have got the hint that how we can prove it. Okay. So this is the formula of expectation. Then given a PMF, PMF means probability mass function, we can just do x into px. Okay, that's the formula of expectation. Let's just do many interesting questions out of it. So let's have this first example. Here they are saying that if we toss a coin and x is 1. If we have a head and 0, sorry, if we toss a coin, okay, and x is 1, if we have a head, and 0 if we have a tail. Okay, x value is 0. They're saying x value is either 0, either it could be 0, it could be 1. If we have a head, okay, if we had a head, then it is 0. If we had a tail, then it is 1. Okay, see what they will give you. They will so what they will give you, they will not give you the random variable probability distribution directly. Okay, they will associate with the outcome. If you do this, then you will be getting 1. If you do this, then you will be getting 0 like this. Okay, the value of the x will be 1 or 0. Then you need to calculate the probability distribution. Okay, first calculate the PMF of x. Probability So tell me, what is the probability that x will be 1? This is the first step that you have to do. When can x be 1? Collect all the outcomes. Do you remember how do you calculate the PMF? See, you have to calculate the PMF this way. You have to collect all the outcomes, all the possible outcomes that give rise to this event. Now just collect all the outcomes. Here, collect all the outcomes that will give you 1. How many outcomes? Only head will give you 1. I mean, if heads, then only it is 1, right? If tail, then it is 0. So basically, it is same as saying probability of head, which is 1 by 2, which means it will be 1 by 2 if head comes, and head is coming with the probability 1 by 2. So it is 1 by 2. Now let me write the probabilities here. So x is equal to 1 and 0 with the probabilities, like in the short form, people say is WP, with probability 1 by 2. WP means with probability. It is not my short form, it is general standard short form, and people say with probability. Okay, with probability 1 by 2, which means x is taking 1 and 0 with probability 1 by 2, 1 by 2. Now can you calculate the expectation? It is basically same as saying summation over x, all values of x px, which means here all values of x. Let me probably, if you are comfortable with the table, let me probably say that what you want to find out the expectation of what? Expectation of x. So let me write all the values of x and then probabilities of that x. So all the values of x is 1 and 0, probability is 1 by 2, 1 by 2. You just take the multiplication of this, then finally answer will be 1 by 2, right? So answer is 1 by 2. That's how you can calculate the expectation. Okay. Suppose that we roll a fair die. If 1 or 2 is showing, let x equal to 3. ठीक है, तो दे आर सेइंग कि x की वैल्यू 3 है, कब है, जब 1 और 2 आ रहे हैं, आउटकम इज आइदर 1 और 2. If 3 or 4 is showing, then x value is 4. If 5 or 6 is showing, then x value is 10. 5 or 6 is showing. This is outcome. Tell me what is the probability of x being 3? It is 2 upon, these are the two outcomes which are coming, 2 upon 6, right? The probability that x being 3, it is 2 upon 6, which means it is 1 by 3. Here it is 1 by 3. Here it is 1 by 3. Now, if they ask you what is the expectation, you can easily calculate 3 into 1 by 3 plus 4 into 1 by 3 plus 10 into 1 by 3, which is 17 by 3. ठीक है? Yeah, 17 by 3 is the answer. So what you did basically, you need to collect all the outcomes. See, you first need to get that PMF. There is no other way. You have to get that PMF, and to get that PMF, what you need to do, you need to collect all the outcomes. Whatever outcomes are there, you need to collect them, and then you will find the expectation. So you need to collect all the outcomes. Then only you can find the probabilities, and then you need to find the expectation. Okay. Okay, so Ekta is asking what is the interpretation of this. See, I will not suggest you to do interpretation in every question, but if you want, you can do it. But otherwise, it is unnecessary. It is the same interpretation, which means on average you will be getting 17 by 3. And what is this 17 by 3 rupees or something else? It depends on the problem. See, they're saying let x equal to 3. If 3 or 4 comes like this, if 1 or 2 comes like this, or whatever. So basically, 17 by 3 is that if you run this experiment enough number of times, on average, you will be getting x value as 17 by 3. Okay, average value. This is the average value. This is not the exact value. X cannot take the value 17 by 3. X will be taking the value either 3 or 4 or 10. I'm not saying that x will take the value 17 by 3. There is any higher probability of taking x equal to 17 by 3. Tell me, probability of x equal to 17 by 3 is what? Everyone tell me. This is what? 0, right? Yes. So x can never ever take this value. It is just an average value, which means if you run this experiment enough number of times, sometimes you may get 10, sometimes you may get 3, sometimes you may get 10, you may get 4, but on average you will be getting, if you take the average, then you will be getting 17 by 3. Okay, x value. This is the average value. Okay. Suppose we roll a die, let x be the value that is showing. We want to find the expectation of x square. This is very interesting question. Why it is interesting? Because earlier what we used to do, we used to find the expectation of x, but here we will be finding the expectation of some function of x. Okay? It is not x, it is a function of x. So let's just understand this problem step by step. They're saying, suppose we roll a die and let x be the value that is showing. Okay? We want the expectation of x square. So let's just write the possible values of x. And what are the possible values of x? 1, 2, 3, 4, 5, 6. Now they have defined a new random variable. And what is that new random variable? It is x square. You can say this is y, or let me just say x square. I mean, y equal to x square if you want, I can say, or let me just say x square. Okay? No problem nahi usme. Let me just say x square. Tell me the possible values of x square. This is 1, 4, 9, 16, 25, 36. These are the possible values of x square. Then tell me the probability that x square being 1, the probability that x square being 4, which means PMF of x square. PMF of x square. PMF means like probability distribution of x square. Okay? If you are not comfortable with writing PMF, let me write probabilities of x square. Tell me what is the probability that x square being 1. It is the same probability that x being 1. And what is the probability that x being 1? Probability of x. It is 1 by 6. 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 1 by 6. So this is the same probability that x square being some value, which means x square being 1 is the probability is 1 by 6 only. Here also 1 by 6. Here also 1 by 6. Here also 1 by 6. Reason being is that x square will be 1 only when x is 1. And x will be 1 with the probability 1 by 6. So that is why x square probability is also 1 by 6. x square will be 4 only when x is 2, and the probability that x is 2 is 1 by 6. That is why x square being 4 is also 1 by 6, like that. Okay, we will do some more questions, and with the complicated example there you will understand the difference clearly. But for now, this is a simple example. I just want to introduce you the function of random variable where we are finding the expectation. So what you need to do, there is a way. I mean, there are actually multiple ways. One of the ways that you list down the PMF of the new function, which is x square. So what we just did, we have our two columns. One is x square and the probabilities of x square. Now can you find the expectation? So expectation will be some same row. Okay. Now can you find the expectation? Expectation, to find the expectation, you can just multiply these, right? You can just multiply these. Which means the expectation will be 1 into 1 by 6 plus 4 into 1 by 6 plus 9 into 1 by 6, like this. Okay. Is there any problem in this? Yeah, Arnav, I will answer this. Anyone else? Is there any problem, or you understood? Okay. So basically what we are doing, we first want to find out the PMF of x square. Okay. Once we find out the PMF of x square, then expectation is easy. And why the probabilities are like this? Reason being is that, tell me, what is the probability that x square being 1? Can I say the probability that x square being 1 is same as the probability that x being 1? Because x square can be 1 only when x is 1. And this is 1 by 6. What is the probability that x square being 4? It means that x is 2. The probability that x is 2. This is same as the probability that x is 2, which is 1 by 6. Right? So that's why the probabilities are 1 by 6 here also. Now, for example, for just a sake of example, let me take a different question where let me say that x is taking different values, -1, 0, 1. Okay, let me say that it is taking these values, -2, -1, 0. Okay. Now let's say there is a x square. It is taking the values with these probabilities. Let's suppose probabilities for x. Okay, I mean probability, it is a PMF for x, px. Okay, PMF for x. So let's suppose this is 1 2 3 4 5. This is 1 by 5. What are the possible values of x square? X square possible values will be 4 1 0 1 4. Okay. Now, can anyone tell me what is the probability of x square being 4? Yes, it is 2 by 5. Reason being is that x square will be 4. This is, see, you just need to go one level down. Okay, if it is a function, you just go one level down. Just check that this 4 is getting contributed by these are the possible values of x square, which is 0 1 4. Okay, this 0 will be coming when x is 0. This 1 will be coming when x is -1 and x is +1. Similarly, this 2 this 2 will, sorry, this 4 will be coming when x is -2 and x is +2. So basically these are the two values that are contributing to 4, and each is having 1 by 5. That's why the probability is 1 by 5. Or in other words, you can say this is same as probability of x being 2 plus probability of x being -2. So this is 2 by 5. Okay? Because these are the two values which are contributing to x square equal to 4. So you need to collect all the outcomes. If the outcomes are directly not visible in case of function of random variable, then you need to collect all the possible values of x that are contributing to your gx equal to something. ठीक है, समझ में आ गया कि पीएमएफ फाइंड करना है और उससे अपने को एक्सपेक्टेशन फाइंड करनी है. But here is a good news. Good news is that you do not always need to find the PMF. Let me tell you what is that good news. See, suppose that's what they are interested in, and then let me just calculate the expectation of x square. So expectation of x square is basically, let me write it here, it is 1 into 1 by 6 ओके यहाँ से इतना जल्दी क्लियर नहीं हो पाएगा, बट फिर भी एनीवे दैट इज ओके। 4 into 1/6 प्लस 9 into 1/6 प्लस 16 into 1/6 प्लस 25 into 1/6 प्लस 36 into 1/6. This is your expectation, which means what you actually did, you found out the probability distribution over y, I mean PMF of y, and you actually did over all y's. Basically, you did y into py. Isn't it? Is this you have done, or you have done something else? You took the value of y, which is 1, 4, 9, 16, 25, 26. You did the same thing, which means you calculated the new random variable and you find out the expectation like this. So it is y into, and see, if we are finding the expectation of y, it is always the py like this, like py and ranging over y. Basically, these two are always same. I will connect the dots. Okay, but for now, understand this. These two are always same, which means if this is y, and then this has to be y, which means if you're working with the PMF of y, that means you will range over all y's. And here generally it is y only. Okay, this is your expectation formula. Okay, but I will tell you in a while that this may change, but these two are bound for each other. मतलब ये तो साथ में रहेंगे ना, क्योंकि PMF are running for y. ठीक है, so these two are always same. Now there is a shortcut to find out the expectation of any function. The shortcut is that this is one way where y is a function of x. ठीक है, मतलब capital में if you want, I can write y is a function of x. There is one another way of to find the expectation of y, which is also very convenient way, very nice way, that says that it is x px. Very interestingly, it is x px. Still you can write just y, which means that you use the PMF of x. It is very convenient way. Reason being is that you do not need to calculate the PMF of y. Basically, it will save you a lot of time. I will tell you the intuitive proof of this formula. Mathematics se nahi, examples ke through I will tell you that you will be convinced. You will be convinced that yes, this is the formula, that is right. So what we are going to do, we are basically going to skip one step. We are not going to calculate this. We are not going to calculate this probability of x square. We no longer needed probability of x square. We can just work with the probabilities of x. Still, we can find the expectation of y. Let's just use this formula in the earlier example. So basically, if you're finding the expectation of y, then you can plug in the y. So whatever you want to find out the expectation, let's suppose you want to find out the expectation of x, then you can just plug in the x, which means expectation of x will be this summation over x into px. This is x. Basically, this is fixed. This is fixed. This is fixed. You can just plug in whatever expectation you want to. You want the expectation of y, you just plug in y. You want the expectation of x, you just plug in x, like this. Okay, let me just show you in this example. So if you do not find the expectation, if you do not find the probability distribution of y square, then what you are going to do, you are just going to say, let me use this way. And what do you which variable you want to find the expectation? Just plug in that. What is that variable? X square, right? Just plug in the x square here. So plug in the x square. Yes. So now x square or y, whatever you want to say. Now it will range over all values of x only, which means x value could be 1, could be 2, could be 3, could be 4, could be 5, could be 6. Let me just say. See, x value could be 1, which means it will be 1 square into probability of 1. Probability of being 1. Probability of being 1 is the distribution of px you already know, right? This is px. This is 1/6, right? So it is 1/6 plus 2 square into 1/6 plus 3 square into 1/6 plus 4 square into 1/6 plus 5 square into 1/6, like this, plus 6 square into 1/6. Just check, is the same as previous one? It was also 1 into 1/6 like this, 4 into 1/6, 9 into 1/6. It is also 1 in 1 square, 2 square like this. So basically, you do not need to calculate it. You do not need to calculate the PMF of x square explicitly. Okay. So it is a simple example. I will tell you in a while that what is happening in some complicated example. But for now, just at least just equate two formulas one by one, which means this is what we got earlier. How? We calculated the PMF of x square, then we found out the expectation using this formula, y into py. That's what we did. Okay, 1 into 1/6, 2 into 4 into 1/6, 9 into 1/6, 16 into 1/6, like this. So we are working with the PMF of x square, but here we are working with the PMF of x only. Reason being is that I have written px, I have not written py. So I will do 1 square into 1 by 6, 2 square into 1 by 6 like this, and this is same. At least mathematically it is same, right? One here I have 4, here I have 2 square, right? Here I have 3 square, here I have 9, here I have 16, here I have 4 square. Mathematically you can easily see it is same. Let's just see it with 1 or 2 more examples, then you will be automatically convinced that yes, it is a nice way. Let's just find out the probabilities, or the expectation of x square in this case using both the formulas, and then we will be able to compare. This is a nice example. Reason being is that here multiple x are contributing to 1 x square. So let's just find the PMF. Let's just say this is a method 1, which is long method. What is the long method? You find out the PMF of x square. Find PMF of x square. Let's just do it. The possible values of x square are 0, 1, 4, and the probabilities I think we have calculated already. This is 1 by 5, this is 2 by 5, this is 2 by 5. ठीक है? This is probability distribution. ये इतना समझ में आया सबको? अभी क्या हो रहा है? एक्सपेक्टेशन निकालते हैं, ठीक है? एक्चुअली एक्सपेक्टेशन के लिए ना हमेशा कम जगह बच जाती है, वो ही इंपॉर्टेंट है, तो थोड़ा मैं साइड में करता हूँ. Okay, so let's just find out the expectation of x square. What do you think? It is same as I mean, you can say it is by, okay, I mean, I'm not writing the formula, but anyway, you can just multiply this 0 into 1 by 5. I'm not writing this this y py. You will get confused that what is this y and all. So you can do what? If you have the table, you can just do 1 by multiplication plus 1 into 2 by 5 plus 4 into 1 by 5. 4 into 2 by 5. Okay, whatever is this number, let's not worry about it. Okay, but this is one way. Can you find out the number? 8 plus 2, 10 by 5, which is 2, right? It is 10 by 5, that is coming out to be 2. So expectation is coming out to be 2. Let's just do it another way. So this is the one straightforward way, but it is a long way. Let's just do it in another way, method 2, which is expectation of gx. Okay, I mean expectation of x square using the distribution of x only, which means this is okay. You want to find out the expectation of what? Expectation of any function, maybe gx. Okay, if you want to find out the expectation of gx, it is gx. You want to find out the expectation of x square, it is x square. With respect to this probability distribution, okay, I mean there could be multiple probability distributions, so that's why I'm saying that with respect to this probability distribution. And generally in the higher mathematics or in the machine learning and all, you will say sometimes p, sometimes q and all. I mean, you will say with respect to what distribution, and they use this notation with respect to distribution of p or with respect to what. Okay, anyway, so this is the formula that we use, where we are directly using the PMF of x, and we are not using the PMF of x square. And then you will say it is ranging over all values of x. Let's just range over. This is very interesting. Let's just range over all values of x. X is -2, then it will be -2 square into, can you tell me what I should be writing here? Into 2 by 5 or 1 by 5? 1 by 5, yes. So it is basically the PMF of x only. X value -2, x value could be, again, x value could be -1 square into 1 by 5. X value could be 0. X value could be +1. X value could be +2. Okay, so this is what we are getting. Now you can calculate it easily. It will also be 10 by 5 or 2. Reason being is that what is happening here, see, earlier what we did, earlier this is 4 into 2 by 5, मतलब एक साथ लिख दिया वो 4 into 2 by 5. अभी क्या किया है, अभी भी 4 into 2 by 5 है, बट देखने का फर्क है बस. Can you spot 4 into 2 by 5? अभी बस वो तो अलग अलग जगह लिखा है. पहले क्या किया था, पहले इकट्ठा कर दिया था. पहले हमने PMF में क्या किया था, we did this. See, when we calculated the PMF, we just collected all the x and then we concentrated on this 4. We calculated the probabilities. Okay, so basically पहले हमने इकट्ठा कर दिया था, and then we are calculating with the probability directly. But अभी हम उसको इकट्ठा नहीं कर रहे हैं, वो अलग अलग है. देखो ये और ये अलग अलग है. ठीक है, मतलब ये 4 into 2/5 ही है, बट उसको अलग अलग जगह लिख दिया है. पहले 2/5 कैलकुलेट किया था and then we got the answer. Now what we are doing, we are basically doing it in two different terms, or maybe whatever different number of terms. Let's suppose that x square equal to 4, x square equal to 4, that is contributed by 3 values of x. Then there will be 3 terms or whatever, does not matter. ठीक है, मतलब मैथमेटिकली हम प्रूव नहीं कर रहे, मतलब मैथमेटिकली भी प्रूव कर सकते हैं, but intuitively just understand that पहले we calculated the probabilities and then we concentrated the probabilities, then we use the PMF of x square. ठीक है, now these two things are same. See, this is 0 into 1/5. Isn't it also here also you are having 0 into 1/5? You are having 0 into 1/5 here. It is 1 into 2/5. Are you not having 1 into 2/5 here? Tell me. Or you are having something else? You are having 1 into 2/5 only, right? This is 1 into 1/5. This is also 1 into 1/5, but combinedly it is 1 into 2/5. And now earlier you were having 4 into 2/5. Here aren't you having 4 into 2/5? It is 4 into 1/5. That is okay. 4 into 1/5 here also, that is okay. So basically अभी हम बाद में इकट्ठा कर रहे हैं. That's the only difference. पहले हमने पहले कर दिया था. Okay, so to find out the expectation of any function, what we will do, we will not worry about the finding out the PMF of that function. That could be, मतलब बहुत टेंशन हो सकती है उसमें. हमें देखना पड़ेगा कि x equal to 4, x square equal to 4 है, कुछ भी कोई भी फंक्शन है. In general it could be gx. Okay, gx equal to 4 किन किन वैल्यूज पे है, मे बी x की इन वैल्यूज पे, उनको कलेक्ट करो, फिर उसकी प्रोबेबिलिटीज निकालो, PMF निकालो. इतना कौन करेगा. ठीक है, what we can do, we can easily find out the PMF like this. If you want to find out the PMF of any function, okay, whatever is this, sorry, if you want to find out the expectation of any function, then what you will do, you will just write x here, px here. Now tell me which function you want. You want x square? Let me just give you x square. Okay, sorry, yeah, you want x square. Let me tell you that you can calculate the PMF of x square like this. Sorry, expectation of x square like this. You, what else you want? You want a sin x. Let's just do sin x. You want x cube, or maybe x cube plus x square minus 5x or anything. Let's just do that. X cube plus x square. Let's say x cube plus x square. Whatever. Okay. You want whatever you want. I can write like this. Basically, it is very easy to find the expectation directly using the PMF of x. We do not need to calculate the PMF of new random variable. And if you want gx in general, you can write gx in. Notice here is that don't mess up this. Okay, this is all values of x. This is PMF of x. Don't mess up this. And this is whatever you plug in here, you can plug in here also. You can find expectation of any function with respect to the probability distribution of x. Any function without even calculating the PMF of that function. Okay, so that's the thing that we can do. Sudeep is asking, sir, it is basically directly multiplying x square and px from the table like this. Yes, right, you understood correctly. Okay, so just see here, this is how you can find out the expectation of any function. Now don't mess up this. This is very important. Okay, I mean, if this is x, this is also x. This is x, then this is a PMF of x. Okay, ये important है. And then you can plug in any function, whatever function you want. This is gx, you can plug in gx. That's not a problem. Okay, so you can find the expectation of any function like this. Let's just find out the range and PMF of f of y, or maybe let me say, instead of these, let me say that let's just find the expectation of y. I think I have multiple examples. Just I was not sure that you will be able to understand with just one example or two examples. But now I think you are understood. So let me not calculate it. Okay. So I will give this also as a homework, because this is a very easy question. You can just do it in both ways or one way. It is your choice now. At this point, it is your choice. Okay. You can just do it directly. Maybe directly. Expectation of y is nothing but summation over this y. Y is what? 2x. Okay, just write 2 mod x. For verification, you can do it in both the ways. Okay, so now you know the expectation and average. Let me quickly summarize in just one line. Key average is same as, or let me write in other words, expectation is same as long run average. Or maybe average, you can write in more better word, average will tend to expectation. Okay, this means tend to expectation if we have large sample. Yeah. So let's see this question. In this question, they are saying that consider a quiz game where a person is given two questions and must decide the question to answer first. Which means there are two questions, question 1 and question 2. There are two questions are given. And question 1 will be answered correctly with the probability, some probability, and the person will then receive as a prize. Agar question 1 will be answered with the correctly with the probability 0.8, and if question 1 is answered correctly, then he will get $100, and question 2 will be answered correctly with 0.5 probability, and if question 2 get answered correctly, then he will receive $200. Okay, that's okay. But there is some other conditions that makes this question more challenging. Now, what they are saying that if the first question, okay, I mean, whatever is the first question is not question 1, which means first, like he has to do the question in the sequence. Maybe the question 1 first and then question 2, right? Maybe question 1 and then question 2, and or maybe question 2 first and then question 1. So there are two possibilities. Either he choose the question 1 first or question 2 first. So what they are saying is that if the first question that attempted is answered incorrectly, then the quiz terminates. So that's the problem. मतलब ऐसा नहीं है कि he will get a chance to attempt both the questions. If first questions get answered incorrectly, then quiz is terminated. If that get answered correctly, then only the person is allowed to attempt the second question. So which means that there are two possibilities. See, he start with the either with the question 1 and he answered correctly, or he say that okay, doesn't answer this, and then he will answer the question 2, maybe the answer question 2 correctly, or maybe doesn't answer the question 2. But tell me, in this case where in the first question he is choosing the question 1 and he doesn't answer this correctly, then can he attempt the question 2 now? See, there are two cases. First is this, another one is this, another one is this. This one, let me write this case. This is where I'm saying, let's suppose he start with the question 1, okay, instead of question 2. Sorry, instead of question 1, he start with the question 2. He start with the question 2. He may answer it correctly, may not answer it, and then he will go for the question 1. So there are two possibilities. Now, they are saying that if first question is question 1 or question 2, whatever it is, if the first question get answered incorrectly, he is not able to answer, then he cannot attempt the question 2. Okay, that's the problem that they are saying. I hope you are getting the question. Okay, my voice is not clear. Can anyone else confirm? Okay, it is fine. Okay. I think it is fine. So now there are two situations. One is that he attempt the question 1 first. Another is is situation where he attempts the question 2 first. Now suppose he goes with this situation, then let's check that how much expected value that he might be getting. So can you tell me that how much value that he will be getting here? He is attempting both the questions correctly. It means how much? 100 plus 200, 300, right? He will get 300 rupees here. He is attempting only question 1 correctly. He will get how much rupees here? 100 is for question 1, 200 is for question 2. How much he will get here? 100 only, right? How much he will get here if he is not able to answer the question 1 itself? 0 rupees, right? Doesn't get any rupees. Now how much he will get here? He will get again 300 rupees here. He will get, I think, 200 rupees here. He will get 0 rupees here. I hope the diagrams are clear to everyone. Now let's just write down the probabilities. What is the probability that he answers the question 1 correctly? I think the given probability is 0.8. Okay. He answers the question 2 correctly, 0.5. And these are independent, which means it does not matter whether he can answer the question 1 or question 2. It does not matter, which means question 2 and question 1 both are independent. Okay. And similarly, this is 0.5 and then this is 0.8. This is 0.2. Okay. Now, can you tell me what is the expected value here, expected price here, expected price. See, just check. I'm getting 300. With how much probability I'm getting 300? With I think 0.8 into 0.5 probability. ठीक है ना? तो value x into px, value into that probability plus how much probability, with how much probability I'm getting 100? I think 0.8 into 0.5 probability. And with how much probability, I'm getting 0, does not matter actually, है ना? मतलब but it is 0.2, so 0.2 into 0 you can write, or it does not matter since it is 0. ठीक है? So this is the expected price in the case 1. Let's just call it case 1. Let me remove this. Okay, so this is the expected price in the case 1. Now similarly, can you calculate the expected price in case 2? I think we can calculate. If we go for the calculation, let me, one second, let me show you. So yeah, so this is your case 1, this is your case 2. Let me remove this case 1 here. Okay, so this is your case 2. Now can you calculate the price that is coming out to be? Let me say this is case 2. This is coming out to be 300 into 0.5 into 0.8 plus 200 into 0.5 into 0.5. So which case is better? I think first term, which is 300 into 0.8 into 0.5 is common in both of them. And 100 into here, 100 into 0.8, which is I think 40, right? 0.4 into 100, it is 40, right? And here, this term is 10 and 20. So which case is better? In which case we are winning the more price? The first term is same, second term is 20 here, and second term is 40 here. In which case, the first one. So you will say that I will attempt the first case. I mean, there is a more likely that expected price in the first case is actually more. So we will go with, we will attempt first question. I mean, question 1 as first. Okay. So this is the answer. This is the question that I have taken from MIT. Okay, this is a question from one book that I'm referring for the probability, which is MIT. Most of the diagram, most of everything, like maybe I mean most of the things, let me just show you, are from that book only. Any formula that I'm using, this screenshot and anything, this screenshot was from the MIT book. And one screenshot that I was taking, collect all the samples, I used that PMF calculation screenshot, right? So anyway, like most of the things that I'm referring are from that book. So there is one MIT book that is very, very nice book. So I'm just referring that book. Okay, it's very, very nice book, and I have referred that in my time of IISc, so I'm more comfortable with that book. So I thought like I will refer that here also. So anyway, why I'm telling you this, that this question was in MIT book, and to my surprise, that exact same question they have, I don't know the data, like the data they might have changed, but the exact same question they asked in GATE 2021. You check the question of GATE 2021. Okay, they have asked the exact same question that was in MIT book, this book. Anyway, so sometimes it happens. Obviously, that MIT doesn't copy this GATE questions. The GATE must have copied the MIT questions. That is for sure. I mean, most probably 99% of the chances are that. And obviously, that book is also very old, not that recent. That question has been asked in GATE 2021, which is very recent, right? Okay. So you just check here. These are the two possibilities, and I'm getting the more expected price from the question 1. Let's understand a very nice, very important rule, which is a law of expectation, law of total expectation. Do you remember law of total probability? It is same as it is law of total expectation is basically driven from law of total probability. We are not going to prove it, but we are going to solve questions based on that. It says that if you want to find the expectation of X, let's just do one thing. Let's suppose there is an event A. You will say if that event happened, then what is the expectation of X? If that event doesn't happen, then what is the expectation of X? Very easy. Okay. So if you want to find the expectation of any random variable X, then you will just check that you will basically say that maybe there is an event. If that event happens, then what is the probability of X? If that event doesn't happen, sorry, if that event happens, then what is the expectation of X? If that event doesn't happen, then what is the expectation of X? That's how we are going to find the expectation of X. Let's just solve questions. Let's just see this. Here they are saying that what is the expected number of tries to get 6 when rolling dice, which means let's first understand this question, that how many tries you need on average. Expected number means on average how many tries that you need to get 6 when you are rolling a dice, which means कितनी बार मैं रोल करूं कि एक ना एक बार तो 6 आ जाए. How many expected tries you think that I should be doing so that we get at least 1 time 6? Any intuitive idea? Like what will be the answer for this question? So basically, whenever they ask the expectation of any general problem, then once the first step is that step 1. The first step is that you make a random variable X equal to whatever they have asked. What they have asked? Expected number of tries to get 6. So X equal to number of rolls to get 6. Okay. Which means whatever they ask, just make a random variable X equal to that thing. I mean, if they are asking expectation of number of tries to get 6, then X equal to number of tries to get 6, and then finally you will say your final answer will be expectation of X. Okay, let's just see how we can find it. So what we can do, we can say that suppose at the start you are here. Okay, you can say that suppose that at the start you are here, and then what may happen, basically you roll a dice, maybe 6 can come and not 6 can come, right? You roll a dice and 6 can come and not 6 can come. Now tell me how many tries that you are making if 6 has come. How many rolls you have made this till this point? You just rolled one time, and then if 6 has come, then how many roll? Just one roll, right? Yes, just one roll. So basically you will say till this point you had just one roll. Okay. Now if 6 doesn't come, then how many rolls you have made this till this point? If 6 doesn't come, then also one roll. But I mean, till this point it is one, but plus there will be something in future, right? I mean, you cannot stop here, but here you can stop. I mean, you do not need anything because you just got 6. See, it will get understood clearly. Don't worry, with more examples. Okay, so we will do 5-6 examples of this kind, and it will be more clear. So understand with this example. See, you are rolling a die, and you will say either 6 will come or 6 will not come. If 6 is going to come, then till now you have made one roll, and you will stop here. That's very important that you will stop here. 6 doesn't come, then also one roll, but you will not stop. I mean, there will be some value. I mean, there are more rolls that you need, right? There are more rolls. Is this okay to everyone? Here you will stop, here you will not stop. First understand this. Okay. So rule of total law of expectation says that, I mean, this term is not important, the total law of expectation or whatever this name is law of total expectation. Sorry, this name is not important. Forget about this name. Okay, this name is not at all important. Forget about this name. We will just do the question intuitively. Okay, let's just see how. So what I'm going to say, that this EX is equal to some probability. Let's just maybe write this formula there also so that you are used to this. So what they are saying, the expectation of X is nothing but based on some event you can divide it. If 6 has come, then what is the expected number of tiles? What is the value of even? If probability of 6 is 1/6 into what is the expected number of tiles that you have done till if the 6 is coming, just one, right? Just one roll, plus probability of not 6 is 5/6. And what is the expected number of trial? This is, I don't know. Currently I don't know. I mean, I will fill this value. I will fill this value. But this template should be clear to everyone. We'll fill in a minute. Okay. अभी थोड़ी देर में fill कर देंगे. But ये समझ में आ रहा है कि अगर 6 आता है, if you get 6, then what is the probability of this? The probability of this is 1/6, or you don't get 6. The probability is 5/6. ठीक है? ये probabilities हो गई. This and this are probabilities. And then you write the even and E2, which means if 6 has come, then what is the number of rows you need total? If just in one row 6 is coming, just one row. If 6 is not coming, then I will figure out that how many total rows I need. Okay? But this template should be clear to everyone. Let me know if there is any doubt here. If there is any doubt, then let me know. Otherwise, we will just try to fill this value. Let's just try filling this value. Okay? What is this value? So they are saying that either 6 will come or 6 will not come. So let me again draw the diagram. I mean that tree where I was saying that you are starting from this point. Then maybe 6 will come and maybe 6 will not come. Till here, the number of rows are 1. Here, the number of rows are 1 plus something, right? I mean, I need more rows. I need some more rows. I cannot stop here. Okay. Interestingly, the more rows that you need on average, I mean, you need to find the expectation. So you are basically restarting your process. I mean, you are rolling something. You got, let's suppose, 5. तो उस 5 का कोई फायदा हुआ क्या? कोई फायदा नहीं हुआ ना. You are again restarting your process. So how many, if E is the total number of rows that you need on average of E of X or whatever, if E is the total number of rows that you need on average, let me just write E, okay, then tell me, if you're restarting your process, at this moment, we will restart our process. If we're restarting our process, then how many more rows you need? E only, right? क्योंकि total E लग रहा है ना, कोई फायदा नहीं हुआ. You are back to square one. You are back to square one. कुछ हुआ ही नहीं. So if whenever you restart your process, you will say that now also I'm going to take E, which means this filling is 1 plus E. 1 till now, see 1 till now वो एक वेस्ट ही है, मतलब कोई फायदा नहीं हुआ है. ठीक है, that 1 is actually wasted, but क्या कर सकते हैं. ठीक है, and in future I will need E more, okay, क्योंकि E ही total अगर रख लें तो in future I will need this more. Getting my point? Okay, don't worry, it will be more clear. First, let's just calculate this E. What is this E? 1 by 6 plus 5 by 6 plus 5 by 6 E. I think E is coming out to be 6. You know? Okay. So it says, it means that you need, on average, you need 6 rolls to get 1 6. Okay? It says you need 6 rolls. Now, the number of expected tries to get at least 1 6, you need 6 rolls. और ऑब्वियस सा लग रहा है ना, मतलब अगर उसकी प्रोबेबिलिटी 1 by 6 है तो 6 बार अगर करेंगे तो आ जाना चाहिए ना एक बार तो. मतलब दिस इज व्हाट प्रोबेबिलिटी सेज, राइट? दैट्स हाउ द प्रोबेबिलिटी इज डिफाइंड. मतलब इंट्यूटिवली अभी अगर देखें तो ऑन एवरेज, मतलब अगर उसको करते, मतलब लाइक प्रोबेबिलिटी 1 by 6 है, मतलब इन लॉन्ग रन अगर तुम उसको लेट सपोज 1000 बार जितने भी बार उसको रोल करेंगे तो 1000/6 बार तो आ ही जाएगा 6, राइट? मतलब प्रोबेबिलिटी 1 by 6 उस हिसाब से. So anyway, so we got the 6 as answer. We will do this same question in 2-3 more ways, but I will go step by step. Let's just do it in more ways. Okay, this was the method 1, and then we will connect all the method very nicely. So this was the method 1. Actually all the methods are interrelated. मतलब ट्री मेथड ये है, बस ट्री मेथड को मैं डिफरेंट तरीके से इंटरप्रिटेशन से बता रहा हूँ ताकि आपको ना पूरा क्लियर हो जाए. Let's understand this method too. So what you are doing actually, you are here, you will say 6 will come or 6 will not come. Now, how many rows do you got here till now? 1. How many rows here? 1 plus something. Let's not worry about it. Okay, जो भी है. But what you are doing, you are restarting your process, which means you will again roll a die. You will say either 6 will come or 6 will not come. Agree with me? Which means till now you got two rows. Till this point, 2 rows you will stop. मतलब जहाँ पे stopping point है, I am writing. Okay. If this is not a stopping point, I am actually making a tree, which is 6. I will again roll, right? If it is not 6, मैंने 2 बार roll कर लिया और 6 आ ही नहीं रहा, क्या करें, है ना? तो I will again roll. If it is 6, then I will stop. If it is not 6, I will not stop. I will say till now I have made 3 rows and I will not stop. What do you think I can grow this tree to what level? I can grow this tree to infinite, right? I mean, I can keep on rolling. Obviously, it will be infinite. So let me just draw this till infinite, which means either 6 will come or 6 will not come. So I will say 6 will come or 6 will not come. Which means here I will say the 4 rows. If 6 is coming till now 4 हो गए ना, देख लो 1 2 3 I mean 3 4, ठीक है, till now 4 rows. And if 6 is not coming, then what will I do? I will roll it again. There is no option, मतलब करें क्या, roll it again, not 6. Then I will say that till now 5 rolls and I will go, there is no 6, then I will do what? I will roll it again. कोई मतलब कोई stoppage ही नहीं है. This is infinite tree. Getting the point? See, there I stopped it very cleverly. I said like, okay, if that idea is not clear, let me just go to infinite tree and let me just tell you that the answer will be same. So let's just calculate the expectation from this method. So the expectation, tell me, you want to find the expectation of number of rows. So number of rows here is 1 with what probability? You will just roll one time. With what probability? You will get this one. With what probability? This is 1 by 6, 5 by 6. Okay. So 1 by 6, 5 by 6. Can anyone tell me? Yes, Akash, that is correct. You will roll just one time. It is having a 1 by 6 probability. So this is the probability. This is 1 by 6. Now tell me, you are rolling 2 times and then you're stopping. Number of rolls are just 2. What is the probability? Number of rolls are just 2. What is the probability? You will just stop here. The probability is 5 by 6, 5 by 6 into 1 by 6. Right? The probability is 5 by 6 into 1 by 6. You will stop after 3 rows. What is the probability? Probability is 5 by 6 into 5 by 6 plus 1 by 6 into 1 by 6. Yes, that is correct. 5 by 6 into 5 by 6 into 1 by 6. ठीक है, ऐसे हम निकालते जाएंगे. मतलब ये 1 by 6 है, ये 5 by 6 into 1 by 6 है, ये 5 by 6 square into 1 by 6 है. ठीक है, good. Now can you find the expectation? I think I have the table, then I can find the expectation. Multiply करते जाएंगे. ठीक है, so this is what we need. So let's just do it. 1 into 1 by 6. So expected value of expected number of rolls are 1 into 1 by 6 plus 2 into 5 by 6 into 1 by 6 plus 3 into 5 by 6 square into 1 by 6. ठीक है, एक बार मैं नेक्स्ट पेज पे जाता हूँ. तो एक्सपेक्टेशन क्या आ गई? 1 into 1 by 6 plus 2 into 5 by 6 into 1 by 6 plus 3 into 5 by 6 square into 1 by 6 plus 4 into 5 by 6 cube into 1 by 6, like that, right? I think 1 by 6 is common, so it is still infinite. Let's just find out the expected value. 1 by 6 is common, and then this is 1 plus 2 into 5 by 6 plus 3 into 5 by 6 square plus 4 into 5 by 6 cube. ठीक है, ये expected value. Let's just find out the series summation. It is, I think, AGP, no? 1 2 3 4. This is AGP. तो क्या आंसर आएगा, कोई बता सकता है? Let's suppose this is E or this is X equal to let's suppose S equal to 1 plus 2 into 5 by 6 plus 3 into 5 by 6 square, like this. And then I think 5 by 6 S is equal to 5 by 6. If you multiply by 5 by 6, it is 5 by 6 plus 2 into 5 by 6 square, like this. Okay, if you subtract, it will be 1 plus 5 by 6 plus 5 by 6 square, like this. So it will be 5 by 6 upon 1 minus 5 by 6, which is 1 by 6, and then this will be 5, and S will be finally 6. Okay, no, S will be, it is 1 by 5 by 6 into 1 by 6. It is 5 by 6 and it is 1 by 6 into 6 by 1. This is 5, and here you are getting 1 by 6s. Okay. So how much you're getting? This is basically s equal to 5 into 6. I think there is something wrong. expectation is coming out to be 5 otherwise. Can you verify the calculation? This is 1 plus 2. 5/6 s 5/6 into 2 into 5/6 square. तो ये 1 plus 5/6 हुआ, ये 5/6 square हुआ. A, oh, this A is 1. Okay, A upon 1 minus R, no? A is 1 here. So it is 1 upon 1 minus 5/6, which is actually, this is 1/6 and this is 6. And then this is, S is 36. Because this is 1/6 S, so S is 36 finally. Okay? So inside this quantity, it will be 36. So since it is 36 and then 1/6 into 36 and finally you got 6 answer. See here, earlier also you got 6 answer and here also you are getting a 6 answer. So earlier it is 6, here also we are getting 6. So a calculation is not important, you can do it later. So basically what I want to tell you that you can grow this tree till infinite level, or you can cleverly stop at the one level. You can say that, okay, let me just stop right away instead of growing it in, because it is a repetitive pattern. So instead of writing the whole tree infinite number of times, let me just say that I will take the extra rows that I will be taking just E, because I'm restarting my process. So you need to identify whether you can restart or not. If you can restart, just write E. If you cannot restart, then what you need to do? You have to draw the tree anyway. Actually, that won't be the case. But I'm telling you that if you're not able to identify whether we can restart or not, just draw the tree the whole long way. Let's just understand in one more way, the almost same way, but let me call it method 3. So what you are actually doing, you are basically getting 6 or not getting 6. I mean, there are only two possibilities. So here you can get 6 by 1/6 probability. Here you can get 6, you cannot get 6 by 5/6 probability. Obviously, you have to stop here with one roll. Let's suppose you are again doing the same thing. You are growing the tree and then you say that it is 6, it is not 6. And obviously here till now two rolls, and here it is probability of 1/6, it is probability of 5/6. Now suppose that at this point, you just realized that, oh, what we are doing, we are rolling it again and again. Basically, I need to restart my process. Now, at this point, can you tell me how much rolls you need at this point? If you want to stop at this point only. See, what I did at the first method, I stopped at the very first level. Okay, I stop at the very first level. I stop at this level only. Here, I am doing in the second method, I have grown the tree till infinite level. But in the third interpretation only, I'm doing what? I'm saying that, okay, I realize it later that I could have stopped, right? I mean, let's suppose I'm realizing at this point that I could have stopped. Then tell me how many rolls I will be making at this point. So see, 2 rolls I have already made. And if you restart, then E more rolls. This is till now. This is till now. And this is for future. Okay, 2 rolls you have already made, and this is for future. So let's just see if I can get answer from this method also. Okay, I mean, these are not different method, it is just only one method, but I just want to tell you that you do not need to mug anything up. Okay, you can you should be able to analyze it properly, that हम यहाँ पे बस tree को grow कर रहे हैं. And at some point in time, we can stop at any point in time. We can stop at very first level. We cannot stop at all. You are unstoppable. You are not stopping at all. In method 3 or in some other interpretation, you realize that, okay, you could have stopped the process, right? So let's just see that how much rolls I need here. So tell me, see, this is one roll with 1/6 probability. ठीक है, ये हो गया. This is 2 rolls with 5/6 into 1/6 probability. है ना, 1 roll, 2 roll. This is 2 plus E rolls with 5/6 into 5/6 probability. This is your expected number of rolls, isn't it? Can anyone solve this, and can you tell me what is the answer you're getting? 25/36, 2 plus 25/36. So this is 1/6 plus 10/36 plus 25/36 and 50/36 plus 25/36 E. This is E. So it is 9/36e equal to 9/36e equal to 16 और 50 66/36 शायद नहीं 54 होना चाहिए यहाँ पे. 9/36. Something is wrong. It is not giving you 6 answer. Let's just see. कुछ गलत है क्या? 25/36, 25, 50/36, 25/36, E, 10/36, E, ठीक है. This is 9/36E equal to 16 and then 50, 66/36. 11/36 है लेफ्ट में. LHS is 11, ठीक है. Y, अच्छा 36 - 25, 11, ठीक. हाँ आ तो रहा है ना, सॉरी मैंने गलत किया. तो E6, ओके. So E6 only, ठीक है. So you can so this method says that if you're stopping at the second level, then also it is fine. It is like कि बाद में समझ आइए बस, है ना, देर आए दुरुस्त आए. तो बाद में समझ आया कि yes you could have stopped. Here you are not stopping at all. Here you are not stopping at all. Here you are stopping at the first level. You can stop at the any level. You can stop at the first level. You cannot stop at all. You can stop at some middle level, maybe the second level, maybe at the third level or so on. Okay, you can stop at any level, whichever level you want. That is perfectly fine. So I hope this method is clear to everyone. Ki if like we will be solving more questions obviously, but for now for this question it is clear. Ki in those kind of questions what we will do, we will write a recursive formulation. मतलब हम e की ही form में e को लिख सकते हैं using the tree method, and then we can solve these kind of questions. Okay, let's just try solving more questions. By the way, this result, if you can remember it, it is better. Otherwise also fine. मतलब in general, we will be seeing this pattern more often. मतलब they will say that the probability of maybe anything. They will say probability of success or anything. Probability of winning a game. Is P. Then expected number of trials to win at least one game or win a game. What is the expected number of trials? So basically, if earlier 1/6 was the probability and expected number of trials we got 6, basically it is 1/p. Okay, we will prove it for the next example, but it is very common pattern. They will say that that probability of head being a head is 1/2. How many trials you need to get head? Then what you will tell here, they will say probability of being a head is 1/2. How many trials you need to get a head? You need 2 trials. Why? Because it is 1/p. Okay, in general the answer is 1/p, which is 1/1/2, which is 2. Basically they will keep on asking these kind of questions again and again in every subject. Maybe in computer networks they will say that probability of sending from a sender to a receiver is, let's suppose, epsilon. Okay, or anything, maybe 0.3. Probability of sending a packet that is successfully get transmitted to receiver is 0.3. How many packets that you need, or maybe how many times you need to send to receiver such that you ensure that okay, that the packet is delivered? How many packets do you need? You need 1/0.3, right? Which is 10/3. So on average, these many packets you need such that you ensure that okay, after these many packets, I mean, if the number of packets are an integer, then you will say this is 3 point something. You will say 4. Okay, so every 4 packet will get delivered. In 4 packets, at least 1 packet will get delivered. I mean, on average. So basically, they will keep on asking this question that if success probability is p, then how many trials you need to make the success happen? The answer is 1/p. Okay, we will prove it, don't worry. But as you see from this question also, they are saying the success probability or the probability of getting 6 is 1/6. Then how many trials you need? It is 6. Okay, it is 1/p basically. If you remember this, then it is actually good, because you are going to see this 1 by p again and again in computer networks, in any other subject, and maybe algorithms also. In the test series, I have put some questions like this. Okay, in algorithms also, I have put in test series some question based on this concept. In computer networks also, they ask in algorithm data structure, anywhere they can ask that probability of doing is this, then how many tries we need to get at least one win, something like this. Okay. Okay, let's solve this question now. So this question has been asked in GATE 2006. They are saying a coin is tossed. The probability of getting head is P. Now, n is the number of random, n be the random variable denoting the number of tosses till the first head appears. Okay, so n is the random variable. It is telling us that number of tosses till the first head appears. Then they are asking expected value of n. Basically, they are asking that how many tosses you need till the first head appears on average. This is average number of rows till first head appears. So how many you need? The probability is p. Then how many you need? Answer is 1 by p. Yes. Let's just prove this. Okay. Let's just prove this. So let's just use our method. Let's just do any of the method. You can stop at any level. Maybe let me call it method 1. Okay, you can stop at any level. Let me just stop at the first level. So basically, either head will come or tail will come. If head is coming, then obviously you will stop after one toss. If tail is coming, then what you will do? You will restart your process. Right here, you will restart your process. So you will say 1 plus something else. And what is that something else? That restart will take e time again, e tosses again. So basically, if this probability is p, then this is 1 minus p. Then you can say expected number of tosses is p into 1 is p plus 1 minus p into 1 plus c. Okay, let's just find out this e from here. EP equal to 1 and P equal to, sorry, E equal to 1 by E equal to 1 by P. Okay. I will say that you remember this result. Okay, don't drive it again and again, because that is more often they will ask you that, okay, what is the probability of winning that? Okay, what is the, I mean, they will ask you what is the probability of, what are the expected number of packets that you need to send to ensure that, okay, you have sent at least one packet, like this. They will ask you these kind of questions. In computer networks and algorithms, they may ask you. I do not remember the exact question that I have put there in the test series. I do not even remember the template, but I have put 2-3 questions, I think, in the test series based on this concept only. And even in the GATE also, they will ask you more often. Okay, so this is very common, that they will say that probability of success is this, then what are the expected tries to get the success. Okay, maybe for the sake of example, let me just do the method 2 also. Method 2, I mean, there is no other methods. Let me just stop at one level. Okay, here I have stopped at one level. Let me stop at 2 level, and let me stop at infinite. Okay, maybe let's just stop at infinite. In hashing also we did it, right? So expected number of hits to get empty slot. Yes, I think we did it. Yes. So actually they will ask you these kind of questions more often. Okay. So anyway, let's just do one thing. I will strongly recommend you to do method 2 and method 3 by your own. Okay. For this question, just draw this tree infinite times. Just draw this tree maybe after 1 or 2 level. Okay. Just do it for method 2 and method 3. Just so I did it for method 1, which means I drawn for just one level. You do it for infinite levels, and you do it for 2 levels only. Okay, don't do it for more than two levels. Just do it for 2 levels, and just ensure that you are getting p 1 by p only in both the methods. Okay, you can do this. This is homework. So this is infinite level homework. I strongly recommend that you should do it. Okay, and this is 2 levels. Okay, so let's do this last question. It is actually very easy question, and then tomorrow we will be doing a similar pattern question where I will draw the tree to infinite level, 2 level, like this. Okay, tomorrow let's not have a off. Tomorrow we will have a class, maybe just one session, and then we will be solving these TIFR gate and these kind of questions. All of these questions are based on that same pattern. This gate question, that TIFR question, all of these questions are based on this tree method, and these are actually not easy questions. I mean, I have to explain it. There is like you cannot solve it just based on the previous explanation that I did. Okay, so I will explain you these questions, and these are very good questions. So these 4-5 questions will take actually just 1 hour. Just 5 questions, I think. Just it will take 1 hour. So we will do it tomorrow. Let's just do this last question. So here they are saying that suppose that 49.8% of the people in the world are male and rest are female. Okay? Which is more or less true. Okay? Also suppose the expected height of a randomly chosen male is this, while the expected height of the randomly chosen female is this. What is the expected height of the randomly chosen individual? So what they're saying that either it could be male or it could be female. So expected height of randomly chosen individual will be, if you choose male, then if probability of male, either you choose male and then there will be some expectation, plus you do not choose male. I mean, basically you choose female. Okay, there are only 2 possible genders here in this case. So you choose female or you do not choose male. And in this case, what is the expectation? Okay. So that is given to us. You can just do it. Maybe the expectations are given. These are this. I think I have in the next slide. So you can convert this 5 foot 11 inches into just foots that you can divide by 12, and then you can get the final answer. How we are getting the answer? Because of the rule that we have, which is the law of total expectation. See this rule, right? Okay, so this is actually very useful rule. It says what, if you want to find the expectation, then you can divide that expectation into 2 parts, 3 parts. It does not matter. I mean, you can divide in 3 parts also. There you will say ex equal to e1 p of a1 plus e2 p of a2 plus p3 sorry e3 e of p of a3, where a1 a2 a3 are partition. That has to partition your sample space. I mean, this is mutually exclusive and exhaustive. मतलब इसके अलावा कोई possibility बचनी नहीं चाहिए. जैसे either male or female, only 2 possibilities are there. So generally मतलब 2 का ही काम आएगा. तो let's not write it. I don't want to confuse you more. I want to give you the enough information that you should be able to, like get top rank in GATE, but I do not want to confuse you with more information. So let's just keep it as it is. Okay. Okay. So this question is done, and now tomorrow we will be solving very good question. I'm keeping those questions in a slide. Maybe 2-3 questions are there. I'm keeping those questions in the slide, but if you want, you can try them, but that is okay. Okay, if you do not want to try, that is okay. But I will say that after this question, there is a question from here. Okay, from here you can try it. This is a homework question. From here you just try it. Okay, everything else we will not solve this in the class. This question, everything else you can try. Yeah, I was talking about that MIT question. You remember that question 1, question A, question 2. That's the same question that they asked in grade 2021. This is the question. This is the question. You can try this question as a homework. Okay. The same as question. I think they have not even changed these values, the probability values. They have just changed this 10 and 20. Okay. Like it was 100 and 200 there, but they have not changed these probabilities even. So you can try this as a homework, and then we will start a new topic tomorrow. Okay. So thank you everyone. We will meet tomorrow. Thank you, Vani. Thank you everyone. Thank you so much. Bye bye. Thank you, Akash. Bye.